Let's move to our topic of the material API. So, I want to say that purpose of this workshop is not to teach how to program exactly by using material API classes. My goal is to provide a conceptual view of material assignment. In my opinion, it will make it easier to navigate through the help material and make it easier to understand the whole functionality of API in question. I want to say that those who are going to release the ideas based on the Woodwork for Inventor API should have knowledge from these areas. They should know Autodesk Inventor operation. They should have good understanding of Autodesk API and programming tools such as Logic, VBA, or C#. They should know how operates Woodwork for Inventor functionality, especially about, if we talk about this topic, especially about Woodwork for Inventor materials behavior. And of course, good understand what functionality the Woodwork for Inventor material API provides and how it works. If you only have attended to my previous seminar, you have already seen the slides. However, I will briefly reiterate some points. Let's examine how Autodesk Inventor perceives the part component. The part file itself contains saved part geometry, its name, part code, material, and other properties that describe the part component. However, this information alone is insufficient to fulfill information explanations about furniture part. Woodwork for Inventor enriches the part model by his own data. You remember this. We can view a part of furniture as a small assembly that is assembled into one piece from separate blanks, which we call workpieces. Each workpiece is associated with the material from which is made. Yeah, we have workpieces, and each workpiece is associated with materials. Woodwork for Inventor creates information that counts for the composition of the furniture parts, which may consist of blanks made from different materials. So we have Woodwork for Inventor functionality that allows the user to manipulate all of these things through the program. So we have Woodwork for Inventor functionality that allows the user to manipulate all of these things through the program interface. Now, let's go further. We will explain how it can be done through the functions of the material API. Let's take quick and simplified, I emphasize simplified look at how Autodesk Inventor stores information about solid bodies. We can look at the entire part information model as an information container into which other information containers are placed. First of all, we have container called part document. This container holds a solid body container that stores collections of face descriptions inside it. So we have face collections, and the faces, as you see, are stored in it. The Autodesk API provides the tools to access and read data from any container and its elements. Also, the Autodesk Inventor API allows the user to assign information created by own to any container of item. It calls attributes. Maybe you know, which you are familiar with Autodesk Inventor API. Additional user information can be attached to the part document. In the same way, such information can be recorded to separate faces. The Woodwork for Inventor Material API provides classes that allows material information to be assigned to the part document or its elements. Elements, I mean the faces. All such recording or changing of information through the Material API will be same as what user would do using Woodwork for Inventor interface. Yeah. Now let's recall what materials the Woodwork for Inventor user operates with. The first group is fill materials. Who is familiar with Woodwork for Inventor know it. This is the material from which the shape of the part is obtained. Another group is covering materials. Cover materials. And if to look from the, how to say, philosophy side, like that, we can associate that fill materials is similar to Autodesk Inventor materials. They bring also, like Autodesk Inventor materials, physical properties of material from which part is made, color properties and so on, rendering properties. Yeah. And covering materials, it's similar to Autodesk Inventor appearances. And you know that appearances can be applied to the faces and change the face appearance. Yeah. So it's also, we can associate like Autodesk Inventor appearances. From in the case of Autodesk Inventor, materials are assigned to part document. And Woodwork for Inventor fill materials are assigned to part document 2. Yeah, we have some operators and we can do it. For this, we use Woodwork for Inventor corresponding function assign fill, an argument of which is a part document. The other argument is palette item object, describing the material in the Woodwork for Inventor terms. It calls palette item object. And we will talk about how to access Woodwork for Inventor palette items a little bit later. And we have also cover materials, and they are assigned to face object. For this, we use the assign cover function, and this arguments differs from the fill material assignment functions. And there are arguments face, to which we will assign the cover material object, cover material, cover palette item object, the thickness of the cover, and the settings of positioning of the cover in the relation to the 3D model. You remember, it's the if you apply edge band, you can ask to be thin or to be on the top of model. So fill materials are assigned to part document, and cover materials are assigned to face. Remember, that fill materials to document, cover materials assigned to faces. Now let's look how to access to the Woodwork for Inventor materials that are in database. The material in Woodwork for Inventor API is expressed as part item object. This object is used as an argument in the assign fill or assign cover functions. If we look to the material selection dialog, we see some reflection of database, and we will see a list of materials that are grouped into the palettes. Okay? Remember, to access to the specific palette, we selected by the palette index number. Need to know that palettes are indexed inside, and we can select palette by index. The palette itself is an object that holds a collection of material records of material objects about materials, and objects about materials. That is found in the Woodwork for Inventor. That it finds in the Woodwork for Inventor database and belongs to a specific palette. A material entry is a palette item that carries all the necessary information to participate in the assign fill and assign cover functions. So I hope that is clear. So we can get a complete list of materials for the designer palette. So when you access to the palette, you get a list, or in other words, collection of the materials which are in this palette. Now there is an important nuance. Keep in mind that palette is a list of all materials which are presented in it. Woodwork for Inventor has materials without coloring coatings, like simple boards, like solids, like rods, and so on. Materials with color coatings, like laminated boards, like kitchen desktops, and so on. And coating materials itself, like edge bands, veneers, and paints. When we get a palette, we have a collection of palette item objects. Let's say we want to assign a cover to selected face. We go through the collection and find the desired palette item, let's say according to the material code. However, this is a cover, so we cannot directly use and such object in cover assign function. Before to use it, you should palette item object to cast to cover palette item object. Programmers know what are talking about. So you need to cast before applying to necessary objects. So we have such picture. Materials without color corresponds to palette item object itself. You don't need to do anything. Material with color corresponds to the palette item with color object, and in this case you need to cast palette item to the palette item with color. And last one is cover palette item, and if you have palette item, you need to if you would like to apply cover material, you need to cast palette item to the cover palette item object. So I hope that for those whom are programmers, it's clear what about this talking. After appropriate casting, you are ready to apply materials to desired objects. for example, fill material to component or cover material to the face. Okay. Next thing is important about identification methods. Now let's talk about how to identify the necessary parts to assign them to the desired model. Somehow you need them to mark inside the model. First of all, if we're talking about fill material, you remember that then we can apply to the part component. The program needs somehow to know which material to which part should be assigned according to its functionality inside of furniture. In the given IPI example with cabinet, the part is are divided into facade components and carcass parts. They may still be one more group, for example, a group like internal parts. In this example, doesn't exist, but you can establish, let's say, part groups in the way as you wish. Yeah. The easiest way to group parts is to create some custom property simply, and say assign values to this custom property, facade or carcass. When you have already done assigned values, it is easy to programmatically traverse the entire assembly and create a set of the facade or carcass parts to which it is easy to assign one or another material. This method is also convenient because using Autodesk Inventor BOM possibilities, it is very easy to change the belonging parts to one or other group. Of course, if you would like to make more secret method to group the parts, it is also possible to create your own application and add additional attributes to the parts. And again, with this program, also you can scan the parts and looking for your attribute and his value, and in this way you can again group the parts as you wish. Okay. Another important thing is question how to mark the faces so that program can identify them and assign the desired material to them. For example, we would like to know from inside the program what is outer faces. Yeah? We think that this is outer faces, and what is the inner faces. Yeah, and what faces should be covered by edge band. It is best to use attributes for this. To record them, you can create your own application, or you can use apps created by other programmers. For example, we have one such app is Nifty Attributes, an app created by Brian Neckens. This guy is he has long relations with Autodesk. He was chief developer in the Autodesk Inventor IPI team, and also he was developer in the Fusion. Now, as I know, he has his own consulting firm. So it allows you conveniently write down or delete your created attributes for any face or part After making faces in such way, marking faces in such way, it is easy to traverse part faces, check attributes, and apply or change cover materials for them. So in this way, you can identify easily. It is done on our, I suppose, from 2022 version. It's more simple way to tag faces is giving them entity names. You know that there are such feature in the program. It is easy to traverse the faces of the part and create sets based on the given names, and to assign one or more other materials by filtering through these faces. It's again legal mechanisms. A few more words about another functionality of Material API. Through the API, you can control grain direction. When assigning a material, Woodworker Inventor automatically calculates the initial direction of the grain. It has its own solver inside and make decision how initial direction looks. And otherwise, we can say that it determines main phase and sets a coordinate system for the Woodworker Inventor part. Do not confuse this coordinate system with the Autodesk Inventor coordinate system. It's different thing. They can match with Autodesk coordinate system. It depends how part is oriented in the beginning of the design, but they can differ totally. If you want to rotate grain, you must specify the angle on which direction of the grain is rotated from the x-axis of the main coordinate system or set by Woodworker Inventor. So you have mechanisms which allows you to control it. Also, through the API, you can manage workpiece oversizes as well, and change the main face to opposite face also. So you have almost all mechanisms which you have on the mechanisms which you can use programmatically inside your program, which you have on the material assignment dialog, and also which you have on the oversize and grain direction control command. So you have this. Okay, there are cases when it is necessary to get answer inside the program to question of which face is the main, for example, faces, which is the opposite faces, because it can be one face or more faces. Again, you get collections of faces, and maybe you are interested what faces is side faces. The Woodworker Inventor API is designed to make such queries and retrieve the face collections that contains these faces. You can ask part what fill materials you have, and also you can get information about coating materials. You pass as argument a face, and you get answer what material is applied to this face. So that's all about what I want to say about Material API.